Alright guys, we have a new problem that we're going to work on, and we're going to use something called axioms of equalities. If you've never heard this term, axiom, it simply means an assumed truth based on observation, and we're going to deal with equality equations. So we have an equation on one side that is equal to the other equation. So we have 2 parentheses x plus 3, close parentheses, equal to 3 parentheses x negative 1. So right away, before we get too caught up in what we're doing, and by the way, axioms of equalities in the way we're going to look at it is simply whatever you do to one side, if you do it to the other, if they're equal equations, it should work out just fine, right? So we have 2 times x here, which is 2x. And we have 2 times positive 3, which is going to be a positive 6. Then we have our equals. And that is going to equal 3 times x here, 3x, right? 3 times negative 1 is going to be negative 3, right? 1 is the multiplicative identity. That negative gets applied to that positive 3. So we have 2x plus 6 is equal to 3x minus 3. And real quick, I'll put it in green here. So we multiplied here. We distributed, didn't we? We just did distribution, right? And this tells us to multiply against everything in there, doesn't it? Okay, so that's all that's going on, and this is where we're at so far in brackets here. We have 2x plus 6 is equal to 3x minus 3, okay? Now, what's a strategy that we can use to get the coefficient and variable from this side to this side, and the number from the constant term 6 from this side to this side, right? Because then we could put if we can get all the variables on one side and all the constant terms on the other side, we can sort out what x is, can't we? And that's using axioms of equalities. That is exactly what we're doing. So we have negative 3x, right? Because this is a positive 3x. So if we subtract 3x from this side, we can cancel it out. So we're going to subtract 3x from the other side. So we're going to bring that negative 3x over here. We're going to subtract 6 from this side to cancel it. But we also have to subtract 6 from this side, right? So what we end up with is 2x, negative 3x, or 2x minus 3x, equal to negative 6 minus 3. So right here, we see these are like terms, right? Because we have a coefficient of 2, and we have a coefficient of negative 3, both assigned to an x. So we simply look at the coefficient, and we sort out the math. So we're at positive 2, so we go to positive 2 on a number line, right? And then we have positive 1, 0, negative 1, negative 2, negative 3, so on and so forth, right? So where did we start? We started at, I'll circle it in green, we started at positive 2, positive 2. We moved in the negative direction, so this way, and we did it 3 places. So we're going to go 1, 2, 3. We end up at negative 1, so we end up with negative 1x. Now 1 is the multiplicative identity, so this says negative 1 times x. So the only thing that really matters is that negative sign, right? We don't need to write the negative 1, so we end up with negative x. Now we can bring down that equals right here. Now we have negative 6 minus 3. We would do the same thing. We would just go to the negative 6 on the number line. So we'd have negative 4, negative 5, negative 6, right? From here, and we'd move in the negative direction. How many places? 3, right? So we'd go negative 7, 8, not right, so on and so forth. So we end up with negative 9, right? So we have negative x is equal to negative 9. Now if we multiply both sides by negative 1, again, because it's axioms of equalities, right? If we do to one side the same as we did to the other, and by side I'm referring to this equal sign, right, should remain a true statement. So we end up with negative 1 times negative x. Well, that's a negative times a negative. We end up with positive 1x, so just x, positive x. We have negative 1 times negative 9, 1 being the multiplicative identity. It's going to stay 9, but the negative times the negative is going to make it a positive, so x equals 9. And we can see how that sorted out, right? And that's an example of an axiom of equality. All right, cheers.